Okay, so the next standard that we're going to be covering is how to find the density of the objects. Could be liquids, could be solids. What this standard is covering, 9.7, says to be able to apply an equation to determine the density of objects based on its mass and volume. So we're going to do a little bit of review because we've talked about density some, and what actually goes into density are two components. The first one is mass. So let's review what mass is. Mass is the amount of matter. When we talk about matter here, we're going to start talking about these things called atoms. Right now we're just going to be referring to them as particles, but the amount of matter, meaning particles or atoms, in an object. When we measure mass in the classroom, as you can see in this picture, we are typically using a sort of a balance scale. We usually use the triple beam balance scale. And don't forget, our units that we will be using are the grams, and that is a lowercase g when you are using little letters. Okay, the next component of density is how much volume an object has in it, liquids or solids. So when we talk about volume, we are looking at how much space an object takes up. So we're really talking about a 3D object here. And if you think about 3D objects, they're going to have dimensions, lengths, widths, and heights. So when we are measuring volume, the equipment that we are going to use is going to depend on what we are actually measuring. So if we're measuring a liquid, what we'll have to use is a graduated cylinder, as you can see over here to the right, that we'll be talking a little bit more about in a minute. When we talk about solids, we are going to use a meter stick, or, here's the key word, or a graduated cylinder. And that completely depends on whether it's easy to measure that object or not with the meter stick. So if it's not easy to measure it with a meter stick, we're going to use the graduated cylinder and look at how much water was actually displaced. So formulas here, it's going to vary, but for a regular shaped object, it will be length times width times height. Okay? And for the irregular objects, we're going to use what we call the water displacement method. And basically what we're measuring here is the amount of water that rises. So if we look at over here for the irregularly shaped object, you can see that you have what looks to be some kind of, I don't know, an eraser or a rock or something, and so they're going to put it in this graduated cylinder. But if you notice the amount of liquid that's in there already, when they place it in there, you're going to see how it actually rises up a little bit. And so what we're looking at here is that is the amount of space that that particular object is taking up, and in here it's 2 units. We don't exactly know what those units are, but when we start doing some examples, that'll make some more sense here in just a second. For your regular shaped objects, the picture over here is basically looking at 3 different dimensions: your length, your width, and your height. And of course, we're going to do some examples with this and how we would actually measure these 5 centimeters, 8 centimeters, and 3 centimeters, of course, with an actual meter stick. Now, looking at the units, this is going to once again depend on whether you're measuring a liquid or a solid. So when we're using a graduated cylinder for a liquid, we will be using milliliters, and the letters that you use for the abbreviation here is little m, big L, and or I guess I should say this should be an or statement, because we are not always going to be using milliliters, or we are going to be using centimeters cube, meters cube, those kinds of things in order to do so. Now, here's one thing that we need to remember, and I want you to write this over underneath those pictures. Remember that 1 ml equals 1 cm cubed. So that's what I want you to write. as one of your symbols. And what we need to remember is the reason that that is important is because if we're using a graduated cylinder to measure a liquid, you have to change the units from milliliters to centimeters cubed to tell us, hey, we're measuring a solid. Otherwise, we're saying we have a liquid or a solid that just turned into a liquid, and that's not what we want to do. So we need to make that very aware. 1 milliliter equals 1 centimeter cubed. Okay, so now we're ready to talk about density since we reviewed both of the terms that actually go into it. So notice what we say here. For the definition of density, it's the amount of matter. So there's the definition for mass in an amount of 3D space. So here's basically where we're going to come up with our formula, because what we have just said are the two definitions for mass and volume. So the formula for density is density equals mass divided by volume. So over to the right of where we just wrote the words, I want us to actually write out the idea that we told you to try to remember in class. This is like the broken heart. So if you write the top half of a heart, and this is what I want you to do over to the right, if you write the top half of the heart and then break that heart in half, so act like you're dividing line here, and then right below that line, you're going to write the bottom half of the heart. It's going to look like the V, of course, and this is our broken heart. So this is an easy way to remember that the mass is always on the top and the volume is always on the bottom whenever you go to divide. When we talk about the equipment that we use for measuring densities, once again, it depends on whether you're measuring the density of a liquid or for a solid. So if we're looking for that of a liquid, we will always use a balance scale regardless of whether it's a liquid or a solid. But we will also have to use a graduated cylinder. Just like we talked about up top, when we measure liquids, we have to use a graduated cylinder. For solids, that is going to be, once again, a balance scale because we want to measure the mass of it. However, we have a choice here depending on whether we have a regularly shaped object or an odd-shaped object. And so if we're measuring a regularly shaped object, we'll use a graduated cylinder. I'm sorry, if we're measuring an odd-shaped object, you're going to measure with a graduated cylinder. Or, if you're measuring a regular shaped object like a cube or something, you will use a meter stick. Okay, so it just entirely depends on what you are measuring, and once again, that comes into play with your units as well. So for liquids, if we go back up and look what it is, if we have mass, because mass is the first thing that we measure, you're going to have grams, and that is going to be on the top, and then on the bottom you would have milliliters, because of the idea of us actually measuring with a graduated cylinder. For solids, it will always be centimeters cubed regardless of whether you use a graduated cylinder or a meter stick, because we're measuring a solid. And so that's very important to remember. Okay, I'm not sure where this actually cut off at because I know my screen went black and I had to go back in. So I'm going to repeat the units. It's already up on the screen. But for liquids, it's going to be grams per milliliter because we are using a balance scale. And then we are also having to find volume, and of course using a graduated cylinder, that will be the case there. For a solid, we're going to always have centimeters cubed because we are measuring an actual solid, and so we have to have grams per centimeters cubed. Like I said, some of that might be a repeat because my screen went black. I apologize. Okay, this next picture is just trying to get you a visual about what density is in comparing mass and volume. If you look at these four pictures here with the dots in each one of them, and you look at the arrow, it says low to high. And so what this is talking about is the idea of density. We said that the amount of mass refers to the number of particles in a substance, and you can see in the first box that there's 5, in the next box that there's 9, etc. So what we're looking at there is the actual mass. How much space it's taking up is that idea that they're inside of this cube, okay? And so that's the volume. So we're looking at density here and how much space and how many particles are actually in that amount of space. And as you change the number of particles, of course, you're going to change the amount of density. So over to the left-hand side of the box that has the 5 little green circles in it, I want you to write the words less dense equals less particles. And over to the right-hand side box where you have all the little green dots in it, I want you to write most dense equals more particles. And so that's exactly what you're looking at with this particular picture. There's a couple of other things that I want you to note as well down below where we talk about something that is floating. Basically, that's just referring to density. So when we talk about something floating, we say that substances float when it is less dense. And what that simply means, once again, is that it has less particles or atoms than the others. Okay, that's what it means when something floats. Just like when you go, if you ever go fishing and you use a bobber and a bobber is going to be floating because there's air inside that bobber, and air has less particles in it than the surrounding water does. When we talk about something sinking, okay, we're looking at substances that sink when it is more dense. And what that simply means, once again, is that it has more particles or atoms, we need to keep that in mind, than anything else. And so this would be the sinker that you would put on the actual fishing line, and it sinks down below the water, meaning that that sinker has more atoms inside of it than the water that it is in. So now let's actually look at some examples here. What I want us to do is look at letter A, and it says in the density column to the left, we need to write what is the most dense substance. And so when we talk about most dense, remember we're looking at things that are sinking here because we are talking about, in particularly this case, a liquid. So if this is a density column, and based on their densities, they're going to sink or float. And so when we're actually looking here, we're going to be looking at this layer where the corn syrup is, because it is on the bottom. So what we're looking at here for your answer of which one is the most dense, it is going to be the corn syrup. Okay, and that is what we're going to be looking at for that. Okay, now for letter B, what we're going to do, it says now if we looked at the density of the unknown substances, so we're looking at the chart over there to the left where it says densities of some unknowns, we're actually going to be looking at the sample, what sample would be more dense, okay, than the corn syrup itself. So replace that line, or write in that line, corn syrup. So if we're looking over there at corn syrup, on the actual corn syrup, we see that the density is 1.02. But if we look over here at this chart, we're looking for a number, if it's more dense than that, we're going to look for a number that's bigger than that. So the number that is actually bigger than that is going to be sample C right here, because it is at 1.15. So that's the answer we are going to write. Now, for letter C, it says if we were to add sample B to the density column, where would it go? So here we're actually going to look at sample B. If we look over here at the chart, we are looking at, okay, sample B, and it says that we are looking at a density of 0.96. I'm sorry, all these things are coming up on the screen. We're looking at a density of 0.96. So if we look over here now at this and trying to find what unknown it's going to be, we're looking, I'm sorry, if we're going to look over here, we're looking to see where 0.96 is going to be fitting in on this density column. And so if we look at oil is at 0.85, water is 1.0. So the answer here is going to be between, the answer is going to be between oil and water. Okay, so for the next example, number 2, we're looking at both cubes are taking up the same amount of space. So when we look at the volume, we're going to say that they have the same amount. Since we also have to look at mass with density, it says which one has the most mass. If you look at the two cubes, the one that has the most number of particles in it is the one on the left. The one on the right has the least number. So without actually knowing a certain number of mass, we're just basically looking at the number of red circles inside of there. So if we're trying to figure out density without actually having any numbers, which one I want us to figure out is the least dense, then the answer to that question is going to be the one that has the least number of particles in it, or the right cube, because they're both taking up the same amount of space, and we're simply looking at how many particles are within it. Okay, for example number 3, we're going to look at an irregular object. So once again, we're going to use the water displacement method. I've already given you the mass of the cylinder, and if you notice, the cylinder is in the graduated cylinders over to the left. So the cylinder's mass is 70 grams. We don't have a scale to measure that with, so there it is. The volume. Now, what we're going to do with the volume is we're going to look at the difference in how much water it actually moves. So right here is where the water started out at about 19 units, and over here the water ended up at about 29 units. So the volume of the cylinder here is basically the amount between those two. So the volume of the cylinder there I wrote in there is 10 milliliters. We'll say those units are milliliters because we're using a graduated cylinder. So what we're going to do now is just substitute it into the formula that we talked about up top, that broken heart. And that broken heart starts with mass, so we're going to type in 70 grams. And we're going to divide that, by the 10 milliliters that we just came up with. What we come up with then is 70 divided by 10 is 7 grams per milliliter. However, remember we just measured a solid, so what we're going to have to change that milliliter to is going to be grams per centimeters cubed, and my computer screen just went berserkos. So grams per centimeters cubed right here. If I can get back in there. Okay. Let me fix this so you can see it a little bit easier because I'm having some issues right there. There we go. 7 grams per centimeters cubed. Okay. Okay, for the last example that we're going to do today, it's for a regular object. This is where, of course, we would use a meter stick to get those measurements over there of 6 meters, 8 meters, and 6 meters. What I want you to write for the 6 meters over here, okay, this is going to be your length, so I want you to write down L over there to the left, and this is going to be our width, so I want you to write a W there, and then this is going to be our height, so I want you to write an H there. Once again, I've given you the mass of this cube. The mass is actually 600 grams. The volume, we have to actually work out a math problem here, so we're going to have to figure out and substitute our numbers in. Volume equals length times width times height, so we're going to substitute the numbers. So the length, like I said before, is 6 meters. The width is also 6 meters, and then the height is 8 meters. So when we multiply all of that out, we end up with my trusty calculator, 288 meters cubed. Okay, so now what we have is the actual numbers that we need to place into our formula. Remember the broken heart, so mass divided by volume. We start with mass. We go with the 600 grams that we talked about and I had already given you. We divide 288 meters into that because that's the number that we just got for the volume. And what we find out is that, with my trusty calculator once again, that the density of this cube is about 2.083, don't forget your units, grams per meters cubed. Okay, that's it for today.